You have probably seen the benchmark charts. Claude scores highest on this test, GPT-5 wins that one, Gemini leads in another category. But benchmarks are not your code base. So I ran a different test. I gave all three models the exact same app prompt, word for word, and one of them failed to produce working code at all. Here is exactly what happened. Before we get into results, let me explain the rules I set for myself so you know this test is fair. Every model got the same prompt pasted in fresh with no prior conversation context. I did not give any model a second clarifying prompt before seeing its first output. I used the default settings on each model, no system prompts, no temperature adjustments, nothing that would skew results in any direction. The app one asked them to build is a simple personal finance tracker. It needed a way to add transactions with a category and amount, calculate a running total, filter transactions by category, and display everything in a readable list. That is 4 features. Not trivial, but not a massive project either. It is the kind of thing a solo developer might actually build on a weekend. I also chose this app specifically because it requires the model to make real decisions. What language should it use? Should it store data in memory or write to a file? What does the user interface look like? The prompt did not answer any of those questions. A good coding model fills those gaps with sensible defaults. A weak one either asks too many clarifying questions or makes choices that create problems later. Claude went first. Within about 30 seconds it had returned a full Python script using a simple command line interface. It chose to store transactions in a local JSON file, which is a reasonable call because the data persists between sessions without needing a database. The code was broken into clearly named functions, and there were comments that actually explained the logic rather than just restating the variable names. I copied the Claude output into a fresh Python environment and ran it immediately with no edits. It launched. I added 3 transactions in different categories, checked the running total, filtered by one category, and every feature worked exactly as described in the prompt. That is a clean first-run pass. No errors in the terminal, no missing imports, no broken logic in the filter function. One thing I noticed about the Claude output was that the filter function was written defensively. If you typed a category name that did not exist, the program did not crash. It just told you no transactions were found. That kind of error handling was not in the prompt. Claude added it because it is the correct thing to do. That detail matters a lot in real development. Now GPT-5. The output came back fast and it looked impressive at first glance. GPT-5 decided to build a web app instead of a command line tool, which is a more ambitious interpretation of the prompt. It used Python with Flask for the back end and wrote a basic HTML template for the front end. Scope-wise this is actually a better product than what Claude built. I ran the Flask app and it started without errors. The main page loaded. I could add transactions through a form, and they appeared in the list. The total updated correctly. So far GPT-5 was looking very strong. But then I tried the category filter, and this is where the first problem appeared. The filter was applying to the display but the total was not recalculating based on the filtered results. It still showed the total for all transactions. That is a logic error, not a syntax error, which makes it more interesting. The code ran fine. It just did not do what the prompt asked. When I pointed this out to GPT-5 by pasting the prompt requirement back in alongside the broken behavior, it identified the bug quickly and gave me a corrected version that worked. So GPT-5 did not pass on the first run, but it debugged well when given clear feedback. Gemini was last. The output it returned was also a web app, similar structure to GPT-5 with a Python backend and an HTML front end. Reading through the code before running it, everything looked reasonable. The routes were defined, the template was present, the logic for adding and filtering transactions was there. On paper it looked like it should work. I ran it. The app started and the main page loaded. I added one transaction and the page refreshed. But the transaction did not appear in the list. I added it again. Still nothing in the list, but the total changed, which meant the transaction was being stored somewhere. The display logic was broken. The data existed but the template was not rendering it correctly. I fed the error back to Gemini with a clear description of what was happening. It gave me a new version. I ran that version and the list now displayed, but adding a new transaction would wipe the previous ones. It was overwriting instead of appending. I sent that error back. Third attempt fixed the overwrite issue but broke the category filter entirely. After 3 rounds of debugging with Gemini, I still did not have a fully working app. Let me be precise about what this means. Gemini did not write code that was completely wrong. The errors were relatively small, but the model kept introducing new problems while fixing old ones. Each correction created a new edge case. That is a specific kind of failure that is actually quite common in AI coding tools, and it is worth knowing about before you commit to one for a real project. So what explains the difference between the 3 models? My read is this. Claude made conservative choices that matched the complexity of the prompt. A command-line app with file storage is straightforward to test and debug. GPT-5 was more ambitious and that ambition introduced one logic error, but the base architecture was sound and the debugging round fixed it quickly. Gemini also chose ambition but had structural issues that kept compounding. There is a broader point here about how you should use these tools. The model that produces working code on the first try is not always the most impressive-looking model. Claude's output was simpler. GPT-5's output was more feature-rich but needed one correction. Gemini's output looked modern but required multiple rounds and still was not clean by the end. Simpler and working beats complex and broken every time. One thing I want to flag about the debugging round specifically. When I gave each model a precise description of the failure, Claude and GPT-5 both identified the root cause in their response before offering a fix. Gemini tended to just give me new code without explaining what had been wrong. That explanation matters because it tells you whether the model actually understood the problem or just made another guess. If you are a developer choosing an AI coding assistant for daily work, here is the practical takeaway. Claude is the safest bet for getting something working quickly, especially if you want it to run on the first try. GPT-5 is a strong choice when you want a more complete product and you are comfortable doing one round of review. Gemini in its current state needs more oversight from you on the debugging side. I want to run this same test again when each model pushes its next major update, because this landscape changes fast. GPT-5 is newly out, Claude pushed a big update recently, and Gemini has been improving steadily. The rankings here could look different in 3 months, which is exactly why a channel like this one exists to keep running the tests so you do not have to. If this test was useful to you, hit the like button. It helps other developers find this comparison instead of relying on sponsored blog posts. Subscribe if you want to see the next one, which is going to be a test of all 3 models on a harder prompt, a multi-file project with authentication and a database. That is where the real gaps start to show. See you there.